We're talking about declarations in C, declarations and statements. So declarations in C are a bit different than what you've seen so far in Java or Python. So in C, you can declare that something exists, and then you can use it. And furthermore, you can declare that something exists. You don't have to define it. You can still use it. It's a bit odd. So I'll show you what I mean by that in a minute. So this quote says that a declaration in C is a language construct that introduces one or more identifiers. Identifier just means name, right? So the name of a function or the name of a variable into the program specifies their meanings and properties. So if you declare a variable, you have to say what its type is. If you declare what a function is, you have to say what its return type and parameters are in modern C. In older C, you would not have to specify the parameters. You would just have to specify the name of the function, and I think you had to specify the return type, but I no longer remember anymore. So basically, a declaration just says that a name exists and you can use it, right? So you have to declare something exists before you can use it, but you don't have to define it, which is odd. So variables you can declare just like you would declare in Java, right? So you can say something like int x or double y, right? If you want to, you can declare multiple variables of the same type using a comma-separated list. And so you can write int a, comma b, comma c. That just says a, b, and c are all variables of type int, right? I would say that in the modern style, people tend to declare variables on separate lines, but this is perfectly acceptable in the C language. Okay, so when you declare that a variable exists, right, it comes into scope, right? And so what that means is the variable becomes alive. It has storage, so it has memory allocated for it. C does not initialize the value of the variable for you, right? So this is, you have to remember this is very important, right? So here we only have declarations. We don't have what are called definitions. So the values x, y, a, b, and c might be anything, right? So here's a little program that does exactly that, right? So it declares x, y, a, b, and c, and then prints them out, right? Every time you run this program, every time you run this program, you'll probably get a different result, right? So notice that x is minus something, right? Y happens to be 0, right? But then the other values are all some random values, right? If you run it again, probably going to get, yes, you get different values, right? So declaring a variable doesn't give it a value. If you're declaring a variable for something like accumulating a sum, you have to make sure to initialize the variable when you declare it, right? So if you initialize the variable, right? C says, the language says that this is a definition, right? So declaration plus initialization equals definition, right? And so now your variables have well-defined values, right? If you run that program, you actually get 1 minus 1 and et cetera, et cetera, et cetera, right? Okay, we saw const yesterday, right? If you declare a variable to be const, then it is read-only, right? Similar to, but not exactly the same as final in Java, right? The word const becomes part of the type. So the type of x is const int, right? It's not just int, it's const int, right? The type of y is also const int, right? Now, unlike Java, right, as soon as you declare a variable to be const, it becomes read-only, right? So if you define it, that's fine. But if you declare it, you're stuck, right? You now have a const variable y, you don't know what its value is, and you can't reassign it a value. So if you try to run this, you'll get a compiler error. Right, there you go, right? So assignment of a read-only variable y. Right? If you get rid of the offending line and you run it, right, y has some random value. Right? Run it again, slightly different, and you run it again, slightly different. Right? So const just means it's read-only. If you create a const variable, you almost certainly want to define it rather than just declare it. Right? Okay, what about functions? So a function in C looks a lot like a Java method, except there are no access or static modifiers in front of it. Right? So that function declaration right there, right, says that there's a function named max2, right? It returns a double value, and it takes 2 double values as its parameters, right? Notice that there's a semicolon right after the function, right? So this is a declaration of a function. There's no definition. So this simply says max2 exists. It returns a double, takes 2 doubles as parameters. The x and the y are not technically part of the declaration. You can actually leave those out, so they don't mean anything as far as the declaration is concerned, right? Only the types matter. Right, so we have no definition. However, in C, you can actually use this function in your program, even though it's not defined. Right? So I can write a little program, right? So this is called uses max2. It declares the function max2, no definition, right? It declares and then defines the function max3, right? So max3 returns the maximum of those 3 values, right? How is it implemented? Well, oddly enough, it calls max2, right? So we find the max of x and y, and then we find the max of that and z, and that's the maximum of x, y, or z. Right? We have a little main method. We've got 3 values, right? And it even calls max3, which calls max2 twice, right? If you compile this, it actually compiles cleanly. Right? So in other words, if you compile it like that, right, it compiles cleanly. So notice that we're not using minus. Oh, so let me show you what's going on here. OK, so here's, we have max2, so I'll just show you. Sorry, uses max2. Right, so there's your program. Right, so if you try to compile it without specifying any options, right? And then what you're trying to, you're asking the compiler to compile the program and turn it into a runnable program, right? And now it complains, right? It says, you get this funny error, it says user bin LD. So on Linux, that's the linker, right? And remember what the linker does? The linker tries to resolve any function calls across compilation units, right? So in other words, in this case here, it's looking for wherever max2 is defined so that it can insert the definition of max2 into your program, or link the definition of max2 to your program, right? We haven't defined it anywhere, so obviously it can't find it, right? So compilation here fails. However, you can in fact compile the compilation unit uses max2.c, right? So I can compile it into object code and it works just fine, right? There's no complete program yet because there's no definition of max2. So we have to complete the definition of max2 in order to complete our program. OK, so to create a complete program, I have to define max2 somewhere. Right? And now what happens in C is typically you have multiple source code files. Each source code file contains variables and functions that are, well, in a well-organized C program, each source code file contains variables and function definitions that are related to one another, right? So it's like putting stuff into a class in Java. You put the data and the methods that are relevant to your class into a single place, right? So C doesn't have a class structure. Instead, what you do is you put everything into a single source code file, right? And so we can create another source code file, max2.c, right? And it contains the definition of max2, right? So the name, the return type, whoa, sorry, I keep on forgetting, can't do that. The return type and the parameter types and numbers have to match the function max2 that was declared earlier. So the way max2 is implemented, you could write a regular if statement. Here I'm using the trinary operator, right? So I think I told you how this works once before. I'll just explain it again. The way this thing works is it evaluates that Boolean expression. If that expression is true, then the result of this whole expression is that. If it's false, then the result of this whole expression is that. Right? So this basically says if x is greater than or equal to y, return x, otherwise return y. OK, so there's my definition. So now I can compile the definition of the function into its own object code file. Right? So I can do gcc minus c max2 dot c. Right? So there's max2.o, right? The object file for max2.c. and there's the object file for uses max2.0, right? And now I can link them together. So now I can do GCC max2.0 uses max2.0 minus O, and I can compile that as uses max2, like that. Right? And now I can run uses max2, and not surprisingly, it says the max of 5.2, minus 1.3, and 4.9 is 5.2. So it works. Right? And so on that line there, right, I'm manually linking the object files together, and then compiling it into, or assembling it all into a single runnable program. Right? So if you have a C program that's made up of many source code files, right, you'll compile each of the source code files separately into the corresponding object files, and then you'll link everything together to produce a final program. Right? Just like that. Right? Alternatively, instead of compiling the files separately into object files, you can just do everything at once. Right? So I can compile the whole, I can do everything just by compiling max2.c, uses max2.c, and then output that to uses max2. Right? And that works just fine as well. Okay, so notice how our program is structured currently. Well, sorry. Cat uses max2. Right, so the way I've structured the program is I've manually inserted the declaration here for max2. Right? Put max2 into a separate file, then compile those two files together, and so on and so forth. This is obviously error prone. Right? So it's very easy to put the wrong declaration in here. Right? Furthermore, it becomes very tedious, right? If I want to use max2 in another file somewhere else, I now have to copy this declaration and put it into that other file, right? And so it's tedious, it's error prone. If you have to change max2, now you've got to change the declaration to max2 all over the place, right? This is not sustainable. So instead, what you do in a C program is you take your declarations and you plunk them into what's called a header file. Okay, so before we do that though, what a lot of new C programs will do is they'll say, hey, we've got this include ability that the preprocessor can do, right? And I know that include takes your file and copies it and drops it into your source code file, right? So if we include max2.c into bad uses max2.c, right? Then what happens is we take that definition in max2.c, right? And we paste it into here, right? That gets replaced with the definition. And now that's great, right? I've got the definition of max2 now, right? I don't have to declare it because I've included it and it's already defined, right? And now I can use it, right? And at first glance, everything seems great, right? So if you go ahead and compile that program like that, everything seems fine. How do I paste into this window here? Like that, right? So that seems to, hey, it works. Right? I can run the program. It even produces the right values, right? So you say, well, that looks like a good solution, but it turns out it's a terrible solution, right? And so you'll quickly find that something is wrong when you try to compile your program in a different way. Right? So if I try to compile max2.c, right, and bad uses max2.c together, like that, oh, that didn't work. GCC minus, max2.c, bad uses minus O, like that. Right? Now you get, now someone complains, right? So again, user bin LD, so that's the linker again, right? Now the linker is complaining, right? And it says in function max2, we have multiple definitions of max2, right? So why are there multiple definitions of max2? Well, what's in max2.c? Okay, so there's the definition of max2, right? what's in bad uses max2.c? Right? Well, it includes max2.c, right? And so this file also has that inside of it, right? So you have two compilation units, right? max2.c and bad uses max2.c, right? And both compilation units contain a definition of max2, right? And you can't do that in C, right? So the error happens because, right, the definition of max2 appears twice, right? And in C, the names of all functions having what's called external linkage must be unique across the program, right? And so the functions that we have, they have what's called external linkage because they're not marked as being static, right? But we'll get to that in a later lecture, right? So if you have two functions with the same name, they don't even have to have the same signet. They don't even have to have the same return type or parameter list. If they have the same name, they can't exist in a C program at the same time, which is really awkward, actually. Right? You can imagine if you have a program that's made up of hundreds or thousands of source code files, some of which you didn't create, it would not be unusual if you had two functions that had the same name, right? And if that happens, they're not allowed to exist in your program at the same time. So that's one of the pretty severe disadvantages of the language, actually. Well, not one of the severe constraints in the language. Right? You can't have the same function defined in two separate compilation units. All right, so what is the correct solution then? Right? So the correct solution is to take your declaration of the function max2, right? So the declaration, not the definition, right? Put it into what is called a header file, right? Now, any source code file that wants to use your function includes the header file, right? So it gets the declaration of the function, but it doesn't get the definition, right? Now, if you have to change your function, you only have to change the function in its source code file and in its header file. You don't have to change it everywhere now. Right? So you need to create what's called an include, or you should create what's called an include file that corresponds to your source code file. Right? So for max2, what you would do is you would make a header file called max2.h. Right? You would declare the function max2 inside that header file. Right? And then you wrap everything up in what's called an include yard. Right? So the include yard are these three lines here. So the include yard starts with if and def max2h. Right? So that's a preprocessor directive. Right? If and def means if not defined. Right? Max2h, that's just a name. So that's just an identifier. Right? So if the identifier max2h is not defined, right, then do everything up to the first end if. Right? So now everything else happens. Right? So it includes the definition, the declaration of max2. Right? It also defines the identifier max2_h. Right? So now if a second program tries to include this header file, the preprocessor knows max2.h has already been declared, already exists. So it does not include the declaration. Right? So the include yard prevents a source code file from including the same file twice, right? Which is what you want to happen. Now inside max2.c, you just include the header file max2, right? Define your function. Right? Anybody that wants to use max2, right, just includes max2.h, right? Not the source code file, right? You include the header file, right? So that gives you the declaration of max2, and now you have a correctly structured C program, right? So your header file always starts with an include yard. The name of the include yard is typically the name of the header file in all caps, right? So the name of my header file is max2.h. So the name that you typically define in the header file is max2.h_h in all caps. Right. Okay, so that's how you're going to structure, or that's how you should structure a C program, right? If you have more than one source code file, you typically have a header file corresponding to each of the source code files that does not include the main function. Right? And then the source code file that contains the main function typically includes all the other header files that you need to write your program. Right? So that's it for declaration. So that's basically how do you create a name in C. So that's basically a declaration. Right? Now statements. So statements should be quick because you all have seen basic Java. Unfortunately, Java basically copied the syntax from C. So a lot of the stuff that I'm going to talk about here should be familiar to you. Right? So a statement is just a fragment of code that's executed in sequence. Right? So just like in Java. Right? So assignment and function calls, compound statements, so stuff in blocks, selection statements, so if statements, and looping statements, they're all more or less the same. Right? So we all know what assignment looks like. Right? Assignment is just uses the equals operator to assign a value. Right? So this says x gets the value 5. Right? One of the big differences between the two languages, you cannot assign to an array variable. Right? So here, I'm making an array x. Right? It has the values 1, 2, and 3. So this is array definition or initialization. Right? You can use the squiggly brackets when you initialize the array. Right? I can initialize an array y. Right? It's also an array of length 3. Right? What you're not allowed to do in C is you are not allowed to assign to the variables x or y. So if you try to write x equals y or y equals x or x equals anything, you get an error. Right? And you get a very strange error in this case too. Right? Notice you get a very long output from the compiler. It's basically complaining you're trying to assign to an array and you can't. I wonder if this is, well, we'll just leave that for now. Okay, so this is awkward because if you're used to working with strings in Python or Java, then you just reassign string variables all over the place. Right? But remember, strings in C are just arrays. Right? They're null terminated arrays, but they're still arrays. So what that means is if you have a string str1, right, and a string str2, you can't assign a new string to a string, right? Which is awkward to say the least. Right? So if you try to run that, it also complains. Right? Doesn't work. So that's inconvenient. Right? You have to remember that this is the case when you're working with C strings. You can also kind of see why Java and Python were created in the first place. Right? It gets really annoying working around some of these limitations in C. All right, so what if you want to call a function in C? Right? Well, that's basically the same as calling a method in Java, except you don't need an object or a class to do so. So here I'm going to include the math header. I'm going to define a value for pi this way. You don't have to do it that way. I've decided to do it that way. Define is that's a preprocessor directive. Right? So that tells the preprocessor to create the name mpi and to give it the value that. Right? What that ends up doing is everywhere in your program where you use mpi, that just gets replaced with that value there. Right? So the preprocessor will actually replace that with that number there. Right? You can do all sorts of crazy stuff with define inside of a C program. So this is just going to compute the sine of pi over 4 and the cosine of pi over 4. Right? And it complains. Why is it complaining? I wonder if it's complaining. Oh, so this one's complaining because I didn't include standard I/O. But I wonder if this has to be inside of a main function. Yeah, I think it actually has to be in a main function. I think that's the problem. Main. Does that work? Yes, that works. There we go. Okay. Oh, so to call the function, right? You just use the name of the function followed by the arguments to the function. So it works exactly the same as in Java. You just don't need an object. Okay, so the brace structure that you're used to from Java, it's the same in C, right? So C uses braces to denote blocks of code. Right? If statements in C work the exact same as if statements in Java, right? So if round bracket condition, right? If the condition is true, then this block happens, right? Else if, right? Round brackets condition, right? If that condition is true, that happens, and so on and so forth, right? So exactly the same as in Java. Switch statements. So I'm not going to use a switch statement anywhere in the course. They are common in C programs, though. So a switch statement lets you switch on the value of an integer variable in C. Right, so in C you can only switch on integer values. Java you can switch on strings. Right? If you want to use a switch statement, so basically you can have a switch statement where you have several cases, so case 0, case 1, case 2, and so on and so on and so forth. Right? And it's will switch into the appropriate case based on some variable. While loops, well, while loops work the same as they work in Java. Right? So this loop runs as long as this condition is true. Right? And so this one, what is this going to do? It's going to start at 1. It's going to stop at 6. So it should print from 1 to 6. Oops, sorry. Control. Oh, I guess this all has to be inside of a main function. So that's off. Oh, it also needs an include here. Right? So that's just, that loop will just run from 1 through 6. Yeah, sorry.
Sorry. For those switch statements,
Yep.
I was just so confused. How's that different than doing like if, elif, and then?
So it's normally easier to write because you don't have to write the if, else if, else if, else if. We can just hit this page if you want. It's normally easier to write, but there's something awkward about it, which I dislike telling people about. So that's why I never talk about it. But sorry. Okay, so basically you're going to switch on. Why do they pick L as their variable? Switch on 1. Okay, so that's normally a variable, but it can be a value. Right? So this one, so if that's a variable, it'll switch on the value of that variable. Right? So if that variable is equal to 1, it will run the code that's here. Right? So up here, if the value is 1, it'll run the code that's here. The crazy thing about C's switch statement is it falls through. So if your variable is 1, right, it goes to case 1, runs, runs that code there, but then it runs the code in all of the other case statements. Yeah, that's the way it works in C. So you have to put break everywhere if you want to break out of that statement. Right, so that's the way it works. So it's slightly easier than if you have a lot of discrete cases, then it's easier than writing if, else if, else if, else if. That's it.
With the if, else, you wouldn't have to break.
You don't have to break. Yeah, here you have to break. Other languages have switch statements and they don't fall through, like the way C and Java do. I'm not sure why they fall through, but anyway, that's the way it works. Okay, do while. So I don't always tell you people in CISC220 what do while does. There is a do while loop in Java as well. Right? So do while, the condition is checked at the end of the loop. Right? So in a do while loop, the body of the loop runs once. Right? So this runs, and then the condition is checked at the end after running the body. Right. Otherwise, it's the same as a while loop. And then, of course, there's the for loop. Right? So the for loop, there's only the counting style for loop in C. Right? There is no for each loop in C. So it's always some variable that gets initialized. Right? So there's your loop variable. The loop runs as long as that condition is true. At the end of each iteration, that thing gets up, that thing runs. Right? And so that's the way. So it's the same loop that you're taught in Java. Finally, there's break. Right? So you can break out of a loop using the break statement. And you can continue the next loop iteration using the continue statement. Right? So continue stops the current loop iteration and goes to the next loop iteration. Right? So that should all be a review for most of you. All right, let's hit another notebook up. Now, what do we want to do here? Well, I guess I'm going to jump ahead to pointers. So we've done all of these except for, we haven't done integers yet. Floating point types, there really isn't much to say. So I'm just going to jump ahead to the pointer notebook. So pointers are new for most of you, I think. Right? So a pointer is in C, basically references a location in memory. Right? So in other words, a pointer stores the memory address of an object. If you have a pointer and you want to get to the actual object, then we say you dereference the pointer. Right? So that gives you the object that the pointer is pointing at. Right? So as an analogy, right, a page number in a book index would be considered a pointer to the corresponding page. Right? So in other words, in the index, right, it says go to this page. Right? It's not that page. Right? The contents of that page are not in the index. Right? You have to go to that page to get to the contents. Right? So to dereference such a pointer, you would flip to that page in the book and look at the page contents. Okay, so a pointer is an object that stores the address of another object. Right? If T is some type, then T star is a pointer that can store an address of an object of type T. Right? So for example, that thing right there, so int star PTR, says that PTR is a pointer to an int. Right? So its type is that right there, it's int star. Right? So PTR can point at an int. So in other words, it can store the address of some int value. Now, in C, it's kind of awkward. You can write this many different ways. Right? So you can write, sorry, hang on. Ugh, excuse me. All right, so you can write int star PTR, like that. Right? So in other words, you can attach the star to the name of the variable. You can attach the star to the type, which a lot of people argue is a lot clearer, right? So int star, that's a pointer to an int, right? Or you can attach the star to nothing, and you can write int space star and then the name, right? So all three are perfectly valid. Let's see. That's the format, that's the syntax that's used by the people who write the Linux operating system. A lot of other C programmers prefer that, and C++ programmers, I think, prefer this one. So no one agrees on how you ought to write or how you should declare a pointer. I think in this course, I always write it that way. Right? So the star is always attached to the name of the object, sorry, to the name of the pointer variable. Okay, so you can have a pointer, right? So pointer stores the address of some object. But before you use that pointer for anything, you have to make sure it actually stores the address of an object. Right? So before I use PTR 1, 2, or 3, I need to make sure they actually point at an integer of some kind. All right, so if you have a pointer and it's not pointing at anything, you can assign it the value null in all caps. Technically, this is defined in standard def.h, but if you include almost any standard library header file, you'll end up including standard def.h as a side effect. Right? So the word null means no object. So int star pointer equals null means PTR is pointing at nothing. If you try to use it for anything except for simple comparisons, you'll end up with some kind of error. The standard says you are allowed to use 0 instead of null. Right? So you can write int star pointer equals 0, and that's legally fine. Right? It's slightly shorter, but seeing null makes it a lot clearer that the object that the thing you're working with is actually a pointer. Right? Because you can assign 0 to anything in C, almost anything in C. Right? So null is a little clearer. Right? So it's important to remember, right? If you have a pointer that is equal to null, you can't really do anything with it. Right? If you attempt to do anything with that pointer, you're almost certainly going to run into some sort of error or not. Right? Now what that means is whenever you have a pointer, so if a pointer is returned from a function or something else, right, you have to check, is that pointer null or not? Right? And so it turns out there's multiple different ways to check, is a pointer null? Right? So If you have a pointer called PTR, then if not PTR, right, that means the pointer is null. Right? So inside the bracket, inside the braces here, you know that the pointer is null. Right? If you prefer, you can write if PTR equals null. Don't write if PTR equals null. Right? It has to be equals. Right? Equals null means you assign null to the pointer. Right? So that means the pointer is null. You can also check for equality to 0. Right? Again, that's arguably less clear than using null. Right? If you want to test is a pointer not null, right, then you just do the inverse of all of those. Right? So if PTR, right, if PTR is not null, then that'll run. Right? Or you can explicitly test, is it not null? Right? Or you can test against 0. Right? I would guess that new programmers will find this easier to read. I think it's more common that people would write it that way. Right? Similarly, experienced programmers, I think, will tend to write it that way. Right? If not PTR means if the pointer is null, rather than writing it if the pointer is equal to null. Right? I don't care how you write it. Write it whichever way is clearer for you. Okay, so a pointer should refer to an object. So if I have a pointer, I really need to make sure that it actually refers to some object. Right? So how do you do that? So remember, a pointer stores the address of an object. Right? So it's a lot like a reference in Java or Python. Right? So in both of those languages, references are ways to get to the object that's in memory. Right? So if I have a variable called a that's an int, right? So it's the object a, right? And I want a pointer that points at the object a, right? Then what you can write is, right, make your pointer and then assign the address of a to the pointer, right? So ampersand a means take the address of a, right? So in C, you can actually get the address of an object, right? Whereas you can't in Python or Java, right? You can get references, but you can't get the actual addresses. So address of, ampersand means address of. Right? And so here, PTR stores the address of the object A. Right? So wherever the computer has placed A in memory, you now have the address for that. So PTR can store a pointer to any int object. Right? So you can legally reassign it. Right? So here we've done the same thing. Right? So A currently points at the object A. Right? If I make a new int B, I can reassign PTR so that it now points at the object B instead. Right? So that's perfectly fine. So you can do pointer reassignment. Right? Similarly, if you have two pointers, you can assign them to one another as long as they have the same type. Right? So I can if I have two int pointers, I can reassign them to one another. Okay, so if I've got a pointer, how do I get to the object that's being pointed at? Right? So how do you obtain? So to obtain the value that a pointer points at, we say that you dereference the pointer. Now, unfortunately, in C, they use the star operator yet again. Right? So notice up here, the star here is being used to indicate that you have a pointer variable. Right? The star is also used to indicate multiplication. And now the star is being used to indicate pointer dereferencing. Right? So it becomes a little bit hard until you get used to it to keep clear what the heck the star is doing in any line of code. Right? Okay, so let's take a look here. So I've got A is 99, right? So A is an int, its value is 99. PTR stores the address of A, so in other words, it points at A. Right? If you have a pointer and you write star in front of the pointer name, right, that gives you the object that the pointer is pointing at. Right? So in this case, star PTR gives you the object A, which is 99. Right? So star PTR is 99 plus 1 is 100. So B is going to be 100. If you print out the values of A and B, not surprisingly, you get 99 and 100. Now, using dereferencing, you actually get the object, right? So star PTR there is literally saying A, right? Because PTR points at A. Right? Whoops, sorry. Right? PTR stores the address of A, so if you dereference the pointer, you get the object A. So that's literally A equals minus 33. Right? So you can assign to the object via the pointer as long as you dereference the pointer. Right? So now I can change the value of an object through a pointer to the object, and that turns out to be very powerful. Right? So notice A is now minus 33. Right? Okay, now remember what I told you about the null pointer, right? What happens if you dereference a null pointer? Right? So here's my pointer, right? It's null, right? Pointers should always point at something, right? This one's pointing at nothing. If you try to use it to do something like dereference it, right? That's going to barf. Right? And it doesn't, the compiler doesn't indicate that there's an error. This doesn't fail until runtime. Right? So you can see here C kernel executable exited with a code of minus 11. It's basically complaining that your program crashed. Right? So before you dereference a pointer, right, you have to make sure it's not null. Right? Similarly here, if I comment out that line, and I try to print out the thing that, oh, what does this do? Yes, if you try to dereference the pointer and print it out, I think, yeah, that doesn't work either. Right? So you can't safely dereference a null pointer. Now the problem is the language says that if you dereference a null pointer, the behavior is undefined. So it doesn't say your program will crash. It just says the behavior is undefined. Something might happen. If you're unlucky, your program keeps running, and you never know that there was a problem. Okay, void pointers. So normally a pointer has a type of some kind, right? So int star is a pointer that points at an int, double star, pointer that points at a double, right? And so on and so forth. C has what's called a void star pointer, right? A void star pointer can point at anything. And it's complaining again because I didn't put this in a main function. So let me just fix this so that we can actually run this. Sorry. I don't print anything out. Okay, so that's good. Okay, now it's happy. All right. So there's X, right? It's a plain old int. Y is a plain old double. String, str, is an array, right? So it's a point, I'll explain what that is exactly in a second. Right? So str is actually an array. Right? Now I've got a void pointer, right? I can store whatever I want. I can make this point at whatever I want in C, right? So I can make it point at X if I want to, right? That's fine, right? I can make it point at Y if I want to. That's also fine, right? Now, notice here the syntax is slightly different here, right? Here, I can make it point to the array str, right? And so what this is actually doing in C is that it's actually pointing at the first element of str, right? So P in this case is pointing at that H in this case, right? But I can make that pointer point at whatever I want, right? If I wanted to, I could make it point at the second character in the array. The syntax would be slightly different, but I can do it. Yes?
So after you initialize the pointer, you can change what it points to by just writing the letter or like what the variable name was.
Yeah, you just reassign to the pointer. Yes, you can reassign it.
Do the star, because that would dereference it.
That would dereference it, that's right. Yeah. Can't dereference a void pointer. So that, you have to be careful with that. All right. So it is an error to attempt to dereference a void pointer. Right? Why? Because the compiler doesn't keep track of what it's pointing at. Right? All the compiler sees is that you have a void pointer, and it says, well, you can point whatever you want. You have to remember, you being the programmer, have to remember what's being pointed at. Right? So the compiler will not let you dereference a void pointer, right? Because it can't determine the type of the object that's being pointed at. Right? Nowhere in the program does it remember what is the type that's being pointed at if you use a void pointer. Right? So for example, right? X is a plain old int, its value is 1. I have a pointer p, points at x, and I want to assign the value of x to y via the pointer p, right? If you try to do that, if you try to do that, the compiler, is this the compiler? The compiler complains, right? So it's warning you, you're dereferencing a void pointer. When you run it, oh, sorry, it doesn't even run. It says the executable will not be executed, right? The error that you get here is void value not ignored as it ought to be, which is odd, right? But it's simply complaining that you're trying to dereference a void pointer and it doesn't know what to do with the value, right? So you might say, well, that's useless. I can point at it, but I can't get its value. You can get its value. You just have to tell the compiler what is it pointing at, right? So again, x is a plain old int, right? P is a void pointer that points at that int, right? If I want to get to the underlying int value, I have to tell the compiler that p is actually pointing at an int, right? Or I have to say that p is actually a pointer to an int. So the way you do that is with a cast, right? So I tell the compiler, hey, that the type of p is really int star, right? So that's what that means right there, right? So round brackets with a type inside in front of a variable name instructs the compiler to interpret the type of p as being that instead. So this just says to the compiler, hey, p is an int star, or is a pointer to int, right? And in C it's called a cast, same as in Java, right? So now that I've told the compiler p is actually a pointer to int, now I can dereference it, right? But notice I have to wrap it all up in brackets, right? And then I can print the value. So this in fact works, right? You get y equals 1. So if you have a void pointer, it turns out they're enormously useful, as you will see in a couple of weeks. They let you do things like implement generic types in C. But you have to remember, as the programmer, you're responsible for remembering what is the type of the object being pointed at, right? You may have noticed that there's a theme in C in that the programmer is responsible for pretty much everything, right? The language will trust you. It'll trust that what you're writing is what you meant to write, which is not always a good thing. You can actually cast this to something else if you wanted to, right? So you can tell the compiler, hey, this is pointing at a double instead, and it will believe you and try to treat that value as though it was a double, right? So for example, and then %f here, and it works, right? So unlike Java, right, if you cast something in C, the compiler almost always believes you, right? So here I've told the compiler, hey, P's pointing at a double. It's not. It's pointing at an int. But the compiler doesn't care. The compiler believes that you're telling it the truth, right? Or it believes that you're telling it what you intended to tell it, right? And so here I'm reinterpreting P as though it were a double, or pointing at a double, right? And then when I dereference it, I get the double value, right? Notice that 1 becomes -0, which is interesting. But anyway, you don't always get the right result if you have an incorrect cast. Okay, so I think I'll stop there because it's almost 20 after, but I'm going to show you how you can solve a bunch of common programming problems using pointers that you can't do in languages like Java or Python. Right? And so we'll look at that in the next lecture. Any questions? Awesome. So have a good weekend, everybody.